All right, can everybody see my screen? Thumbs up if yes. Yes, okay. So this will be a demo showing web scraping into a SQL database using anime. So the goal will be to use this website, myanimelist.net, to compile a SQL database of various information about anime. We'll be looking specifically at the ID for each anime, the name, the number of episodes, and then some of the recommended shows if you like that particular one. So we can first just take a look at the website here. It kind of just has every single anime you can imagine. In particular, we're going to be looking at the 10 most popular, or I guess this lists it all the way. I don't know how many there are, but this is the list of the most popular anime. So we're going to grab some of these and grab that data on them. So to start off, we just want to import our libraries. We need requests. We need beautiful soup, pandas, all the usual stuff. Then we create our URL string, which is this most popular site here. We get the response, and then we parse it through beautiful soup. So we'll go ahead and run that. And so from this, the thing that we want is the link to each of these shows. Because if you click on one of them, you can see it takes you to an individual page for that particular anime. And this is where we'll gather a lot of the information. It has the recommendations here and so on. So if we want to get that link, we can go to our best friend inspect element. And we can see it highlighted this element here. It's an A tag. And we can see that it's under a div that has a class of this here, diib clearfix. So I'm thinking we can just use that, try and search for all of those elements in the page. So if we go back here, we can create an array to populate for the URLs. We can use find all, look for all the divs with that class attribute. And then once we find each one, we want to get the A tag, and we want to set href to true to get the link. And then we want to get that href to get the link itself, the text of it. So if you look on here, you can see it's an A tag, and then the href is the link that we want to go to the individual page. So if we run this, it should get all the links. This just prints out the first 10. So now we'll get into kind of the more serious stuff. This looks like a lot of code. I'll try and break it down. What this function here does is basically scrape each URL that you pass in, and it gets the ID, the name of the anime, the number of episodes, and then the top 2 recommendations. And so we're going to use this function on some of the most popular anime, and then it will return some of the recommended ones. So then for the recommended ones, we also want to pass those into this function to get the names, the ID, and the number of episodes. But when we go to the recommended episodes, we don't want to get their recommendations too and end up in like an endless cycle where we scrape the entire website. So that's what this rec equals false flag does. This tells us where we want the recommendations or not. So initially, when we're just passing in the popular anime, we will set it to true. And then when we pass in the recommended ones, we'll set it to false, so we won't end up in that endless cycle. So if you look in here closely, you can see that we just make a request to it. We pass in the URL. We'll print out the status code just to make sure it works. We'll parse it with beautiful soup. And then the ID is actually really easy to get, because if you look back up here at our URLs, you can see that all of them have the same format. And this number here after anime slash, that's the ID of it. So to get that, all we have to do is split the URL string and get the 4th element in that, and that'll just give us our ID number. So that part's super easy. Now for the number of episodes, if we go to a particular anime page here, we can see on the left-hand side, there's episodes and then a number. So if we go ahead and highlight that, inspect element, and here we can see that episodes is in a span tag, and then the number of episodes comes right after it. So if we search for a span tag with text equal to episodes : we should be able to find the number of episodes on each page. So if you come back to the code here, you can see we just use a single find because we just want one result. We want a span tag. The text is equal to episodes : and then we want the, this should actually be next sibling. You'll want to change that. That will grab the number of episodes. And then we just want to strip it because it's a string and we want to make sure there's no new lines in it or anything. Then for the name, we'll go back here. The name, I'm thinking we'll just grab it from the top. So let's go ahead and inspect this element. We can see that it's under a span with item prop. And we can also see it's just under an H1 tag. And I already looked through this, but it's the only H1 tag. So we can just use that actually to find the title. So if we go back here, we can see we find the name through soup.find H1. We get the text of it and we strip it. And then you just print out the name so that we can see that we're making progress through it. Then for the recommendations, go back to the page here, you'll see we actually have to follow another link. So we'd have to click on recommendations. It opens a new page with the recommended shows. But you can see the URL, all that changed is they added a slash and then user recs. So that's really easy. We don't have to scrape the URL. We can just make it ourselves. So if we go back here, we can just do our base URL plus that slash user recs, make a request to that page, parse it with beautiful soup. And now if we want to get, we're just going to worry about the top two recommendations because there's a lot and this gets really time consuming, as you'll see in a moment. But so we just want the link here to this first one. So we'll go ahead and do inspect element. And we can see that it's a link here under an A tag. And then it's directly under a div with style equal to this margin bottom 2 pixel. So I'm thinking we can use that style to specify which div we want. So if we go back here, we see that we find all the divs with that style. And then you can pass in a limit too, so that you only get 2 back, which is really easy. And then for each of the recommendations, you want to, let's see here. So for each of those recommendations then, each of the 2, you want to go through and find the A tag, and again set href to true and get the link. And then we just want to append that to our rec URLs list. And then the ID, just like we did before, we can just get from the URL by splitting it where the slashes are. And we can add that to our rec IDs list. So then we just return the main ID, the episodes, the name, the rec URLs, and the rec IDs. So now this next part, so I might have mentioned before, some websites don't like you web scraping them a whole bunch. If you make a lot of requests, they'll kind of kick you out and give you an error message. So there's a few ways to prevent that. The first is to pass in a header with user agent set to something like this. It's basically telling the website that, hey, I'm just a normal computer, I'm just a Firefox browser or whatever, like definitely not a robot here. And then the other thing you can do is add some human behavior to your calls. So instead of calling repeatedly as fast as you can set kind of a random delay between each call to make it seem more like a human clicking on these links. So we'll just create a sleep min and a sleep max, which you'll see how we use those later on here. And now we just have to do kind of a for loop through, we're just going to look at the first 5 most popular shows because you'll see how long this takes here in a second. So we'll kind of loop through each of the URLs. We'll pass it into our function that we had up here where it scrapes the page and gets the recommendations. We keep a set, which means we have all unique values of IDs because there's a chance that one of our recommended shows could be one of the popular shows. So we don't want to scrape that page twice. So we kind of keep track of the sites that we've already visited. And then once we've gone through and gotten the data from the main page, we go through the recommended ones and get the number of episodes and the name and kind of store all of those in list. And now you'll see here we have time.sleep. What this does is gives you a pause So it sleeps for a random amount of seconds between the minimum and the maximum that we did. So between 0 and 1 second, it just waits before it does another call. And like I said, that kind of helps you seem more like a human and not get kicked out from being able to scrape the website. So we'll go ahead and run these cells now. And then I also have a time function here. So we'll see how long this takes. This is just to scrape 5 websites and their 2 top recommendations. And the numbers here, that's just the status code. We should be seeing 200. That's good. If you see something like 489, that's bad. That means it detected you're a robot. And there we're done. So that took 33 seconds. And that was only 5. So you can imagine if we extend that to like 100 or 1,000, how much time it would actually take. So now that we have all that data scraped down, we're going to load it into a SQL database. So to do that, we just have to initialize and connect to the database here. And now we'll create the first table, which will just contain the anime's ID, the name, and the number of episodes. So we'll execute this command here to create that table. And now we want to insert the data into the table. So this is kind of the way you do that when you want to insert different variables that you don't know what they are exactly and you're kind of doing it in a loop. You can do insert values, and then you could put question marks as placeholders. And then outside the SQL command here, but still in the execute function, you can pass in the variables that you want to use. So what this does is takes our 3 lists of IDs, names, and episode counts, zips them all together, and then iterates down them, and it plugs each one into a new row in the table. So we'll run that. And now we want to make sure that worked. So we're going to do a select all from that anime table and just load it into a data frame so that we can see how it looks. And there we have all the IDs, the names, and the number of episodes. So now to use the recommendation data, we're going to create a second table called recs. And it's going to have the primary ID of the show, the first recommendation ID, and the second recommendation ID. So we'll go ahead and run that. And similarly to above, we will loop through and insert those values into the recommendation table. And then we will do a select all and load it into a data frame. So there we have our top 5 shows and the top 2 recommendations for both of them. And now that we've added these tables to the database, we want to make sure to commit it so that it's saved. So we'll do that there. And now just to kind of finish up and connect to the rest of the SQL stuff, we're going to do kind of a more complicated SQL command here that you might not have seen before. So what I want to get is a data frame that says the name of the show, the name of the first recommendation, and the name of the second. And I want it to say, if you like this, try this, or that. So you can see here, I select the name from the anime table as if you like. I select the second name as try and the third name as or. And now you'll see here, I join the anime table with recommendations like you would expect. But then I also rejoin it with the anime table twice. So what this does is lets me grab the name of the first recommendation and the second recommendation. So now if I run this, you'll see what it kind of looks like. So now it's set up really nice. If you like this show, try this or that. And yeah, that's kind of it. You might not have seen this before, really kind of joining a table on a table that you've already joined on, but it does have its uses as seen in this example. And yeah, does anyone have any questions on this? I know I went kind of fast. Any questions?
I just want to point out that the group by variable is kind of becoming an index. Sometimes when you first encounter group by, you think it's going to be the object of interest, but it's not always necessarily the object of interest.
Did this make sense to you guys? Like, how are you feeling? Thumbs up, thumbs down, thumbs sideways? Seeing some sideways, thumbs up.
What about if you guys get it, but you don't like it? That could be like one of those kind of things. More practice, and then it will gradually become likable.
Maybe just a high level question, Matt. So how would you deal with instances where like your rules didn't work? You know, so like you thought you had the right rule, but maybe it only applied in like 80% of the cases.
Do you mean like on my tags? Like if some of the pages were formatted differently?
Yep.
So in that case, you'd probably have to do a lot of like digging beforehand before you set it up on a loop, and you'd probably just want to have some like if statements to catch it. So, detect if, oh, this page has a different format. In that case, use this other method to find the element I need.
Gotcha.
But usually you just hope that, the website made everyone the same and they didn't do something different on each one.
Is that usually the case, just like in your experience?
Usually, I mean, on a site like this, on smaller sites, newer sites, it might not be. It kind of just depends.
Another question I have is, do you happen to know if basically if a website recognizes you as a non-human user, would it recognize you going forward typically, or would it just be for that single query?
I think some websites have that technology. They can kind of flag your IP address even. Some can like rate limit you for a certain period of time. They'll lock you out. Others, like this My Anime List, when I was trying this out, I would just get an error code back. But if I slowed down my calls, then I would get successes. So this one doesn't look like they block you out, but some other sites who are more serious about protecting their data and stuff, they might do that.
Gotcha.
In which case, there are other methods to get around that. There's a program called Selenium, which basically automates opening websites on your own computer. So it doesn't do it really through code. It just kind of opens up multiple browser pages and actually clicks on them as if you're doing it. So that's something to look into if you're interested.
Thanks.
I also have a question about like the database itself. Where did you say that like this data is, or like where did you create the database?
Okay, let's go back up here. So this is where I create the database object. You can just pick any name. It'll just create a temporary DB file. Then I add a table to it, populate that table, add the second table and stuff. And then when I do commit, that's when it saves it to file. So then if I go to my file explorer, like I could see it there, I could open it in another notebook.
Okay. Very cool. Thank you.
Anything else?
Okay. One thing that you guys are going to kind of learn going through SQL Island that was not necessarily explicitly covered is being able to set new items. So let's say we want to update somebody's income from $25 an hour to $30 an hour. You can go back in and use the set command. You just set blank in this table and provide the new one. It's exactly as simple as it sounds. If you will look in your repo, you will find a nice, colorful 3-page SQL cheat sheet with lots of options. I would like for you guys to have it ready. And also kindly click on this link and select English. For those of you guys who didn't see it on Slack, I was looking for a more interesting way of practicing SQL than me just asking you to make a bunch of tables in a study group. And believe it or not, somebody, a very kind German person, developed a text-based SQL game in 2015. And I thought this is going to be awful. But actually it wasn't. I loved it so much that I thought that I would give you guys the option to play it. So let me go ahead and show you. So in the beginning, it will give you a little tutorial. You're not in your Python environment, but this will walk you through plenty of options. So we're starting off, we've crashed, and ultimately we have to buy a sword, we have to collect items, we have to assign users to the items, and then reevaluate and negotiate and sell. And we end up doing all of this through SQL queries. In order to avoid all of us just sitting here awkwardly in silence playing our games separately, I would like for us to divide into breakout rooms in pairs. And we will be playing this for a while yet, but every so often we might bring everybody back to the homeroom and then divide them into new pairs so that you guys may talk with one another and share your experiences. And we will pause recording after we get people into their breakout rooms. Is everybody's game working?
So basically just write in the white window and submit?
Yep. So how can I see a list of all inhabitants, for example? So we'll do select from inhabitant, and since it's the asterisk, should get all of them. Oh, we need a space. That's what's going on. Yep. So type it in the white box. I don't know if you guys were alive and gaming during the original Quake games, but the very oldest ones were text-based like this. It was fun stuff. All right, creepy hands when your game is up and running. Okay. I love you guys. I'm so glad to be in this cohort. All right, let's go ahead and throw them in.